sklearn, linear model, ridge. Description. Ridge regression is a linear regression model that adds a penalty term to the loss function. The penalty term is based on the sum of squared coefficients. This penalty term helps to prevent overfitting by shrinking the coefficients towards zero. Ridge regression is particularly useful when the number of features is large and the features are highly correlated. Inputs. X a 2D array of shape n samples. N features representing the input data. Each row represents a sample and each column represents a feature. Y a 1D array of shape n samples, representing the target values. Outputs. Core a 1D array of shape n features, representing the coefficients of the linear model. Intercept a scalar representing the intercept of the linear model. Steps. The model first calculates the loss function, which is the sum of squared errors between the predicted values and the actual values. The model then adds a penalty term to the loss function. The penalty term is based on the sum of squared coefficients. The model then uses an optimization algorithm to find the coefficients that minimize the loss. Function. Metrics. Mean squared error MSE, the average squared difference between the predicted values and the actual values. R squared, a statistical measure that represents the proportion of the variance in the dependent variable that is predictable from the independent variables. Visualization plots. Scatter plot of the predicted values vs the actual values. Residual plot of the errors vs the predicted values. Fine-tune parameters. Alpha, the regularization strength. A higher alpha value corresponds to a stronger penalty. Solver, the optimization algorithm used to fit the model. Fit intercept, whether to calculate the intercept of the linear model. Uncertainty methods. Confidence intervals, the range of values within which the true coefficient is likely to lie. Prediction intervals, the range of values within which the true target value is likely to lie. Challenges and fixes. Challenge 1, overfitting. Sample use case that resulted in challenge 1 when the number of features is large and the features are highly correlated. The model may overfit to the training data. Fixes to challenge 1: increase the value of alpha. This will shrink the coefficients towards zero and reduce overfitting. Challenge 2: underfitting. Sample use case that resulted in challenge 2 when the value of alpha is too high. The model may underfit to the training data. Fixes to challenge 2: decrease the value of alpha. This will allow the model to fit the training data more closely.